This set of notes is about gas properties or factors that affect gas behavior. There's a set of Cornell notes in your Schoology for you to follow along and fill in with this presentation. If you have those already, you can go ahead and date and topic these set of notes. All right. When we talk about gases in this unit, we're really going to be focusing on gas behavior, or in other words, how gases behave when conditions change. Okay, what do we mean by conditions? Well, some different things that can change about gases is we can change the pressure of the gas, the volume of the gas, the number of particles of the gas, and the temperature of the gas. Okay, all of these things are things that we need to understand what they are and some definitions of them. So that's what this set of notes will go through. Let's start with pressure. For pressure, the abbreviation we use is P. Definition of pressure is the force applied over a specific area. So you can sort of think of this in terms of if you took your single index finger, your pointer finger, and you pushed it into the palm of your other hand, you would feel the pressure, that pressure. But if you took your fist and you pushed with the same amount of force, you wouldn't feel as much pressure going on with those. So again, it's force applied over a specific area. In gases, force, or the pushing force of a gas particle, is based on collisions, on particle collisions. Okay, both those particles colliding with each other and those particles colliding with another surface, like the outside of a balloon. Okay, the force, or the pressure in this particular case, is controlled by a couple things. One, the speed of collisions, because faster collisions make more pressure. If you can think about this, if you have something fast and it hits you, it's going to create more pressure on you than something slow hitting you. Second thing is the amount of collisions. When the particles are moving faster, there's going to be more collisions, and that's going to create more pressure. For this one, we can think about that like if you have more things hitting you or more fists hitting at you, you would feel a greater pressure along the way. Okay. Last but not least, for units, the primary unit that we use in chemistry is the atmosphere, but other units that are used are millimeters of mercury, the standard metric unit of the Pascal or the kilopascal, or even like in our bicycle tires, pounds per square inch, which is not a metric measurement, but it's one that we use every single day. But for purposes of chemistry, we are going to be using atmospheres as our unit. And 1 atmosphere is actually the average air pressure at sea level on us here on planet Earth. Second property or factor that we want to talk about is volume. Volume we're going to abbreviate with a V. And by definition, it's the amount of space that gas particles take up. It is controlled by space. If the particles are in more space, there's more volume. If there's less space, there's less volume. More space, more volume, less space, less volume. Units we measure to this are the same units we use to measure liquid volume or anything else. It's liters. Sometimes we'll also use milliliters, and we want to remember that 1 liter is equal to 1,000 milliliters. That might help us out in doing some conversions as we work along. The third factor that we want to talk about is the number of particles. We abbreviate that with using an N, and it's basically how many gas particles are there. And this gets controlled by the amount of moles, right? We've learned this year that in chemistry, we measure the amounts of chemicals using moles. So more moles, more particles. That makes sense. Oh, a little joke for you. How does Avogadro get across the desert? He crosses and rides on a camel. All right, units that we're going to use to measure the number of particles, we are going to measure moles. And we might need to remember that sometimes in order to figure this out, they might give us a chemical amount in grams, and we might need to change that to moles using dimensional analysis and the molar mass. And last but not least, the very last factor that we're going to deal with here is temperature. For temperature, we go ahead and we abbreviate that using a T. Okay. By definition, temperature is the average kinetic energy of the gas particles. And kinetic energy depends upon two things. The one thing that we're going to be most involved with here is the speed of those particles. And it can be controlled by adding or removing heat. More heat means more temperature. And we can see over here in terms of speed, more temperature or a higher temperature means they're moving faster. A lower temperature means the particles are moving slower. Okay. Units that we use to measure temperature. For the purposes of gases, we are going to use the unit of kelvins. Okay, K. And Kelvin goes up by the same amount. 1 Kelvin is the same as 1 degree Celsius. In our country, we use primarily Fahrenheit to go ahead and measure temperature. But again, in the metric system, we use Celsius or we use Kelvin. Most of us are probably used to Celsius. So you might say, how do I figure out Celsius from Kelvin? Well, it works this way. In order to get a Kelvin temperature, we take Celsius and we add 273 degrees. All right, so here's a couple quick checks on temperature. First of all, it says standard temperature is 0 degrees Celsius. How many Kelvin is this? Take a moment, use the information on the previous slide, figure that out. All right, so how do we figure this out? Well, we've got 0 degrees Celsius. And it says to get to Kelvin, we have to add 273. So the answer should be 273. Let's check. Hey, sure enough, I was right. How about room temperature is 21 degrees Celsius? How many Kelvin is this? So once again, we're going to go ahead and we're going to go, you do it for a second. Come back. 21 degrees Celsius plus 273 Kelvin. That gives me 294 Kelvin. Were we correct? Let's see. Yep, sure enough, we were. Awesome. All right, so this means that at some point you can get down to a temperature of 0 Kelvin. And that is the coldest temperature there possibly is in the entire universe. And that temperature is known as 0 Kelvin. All right, so to finish today's work, the very last thing I'd like you to do is go back into Schoology, and if you would please watch the temperature video that's there and take some information from that. Otherwise, that's it for this set of notes.